Welcome to my talk, Zap the Flakes, leveraging AI to combat flaky tests with CANNIER. My name is Daniel Hiller. I'm principal software engineer at Red Hat. A bit more facts about me is I'm a software engineer in the Red Hat OpenShift virtualization team. I take care of the Cupid upstream CI and automation in general. My main concerns are looking at a healthy prowl instance that we run for our user base, at the CI health, where we look at the stats that with which we look at how we are doing with regards to CI performance. And basically, one of the main topics that I look at is flaky tests. So let me start with, if my clicker works. Oh, OK. It doesn't work. So I have an agenda which is pretty quick. Like I'm going to introduce what Flakes are. I'm going to introduce how we are trying to tackle that problem. Then I'm going into explaining what the CANNIER approach does for that matter. Then I'm going to expand a bit on how we are going to use it. And then I'm looking forward to have an hopefully extensive Q&A session where you can ask questions or just talk to me about how you are using it. Probably I would especially be interested in that part, because I think that is something that is that everyone conquers at some point in time. So about Flakes. Can anyone, with the knowledge, when I'm telling you that in the upper part you see like an overview of all the test runs for one pull request that has been added to a repository, and you see like the test runs, and if the red ones resemble like failed runs and the green ones resemble past ones. And when I then also tell you that this number here is the commit ID, I hope you got it. OK. What do we see there? Could anyone answer here this question? Yeah. Yes, exactly. Because what this tells us is that nothing has changed because all the tests here have been run on the same commit ID. So no changes inside the code base. And that's exactly what we're searching for. Yeah, I need to rely on spacebar, I think. So basically, like my poor definition of a flake goes like this. For me, or for probably also other people than me, a flake is a test that, without any code change, basically, will either fail or pass in successive runs. So just as we saw before. I've read a survey about flaky tests, which actually is pretty interesting because it groups like lots of other surveys about flaky tests together and distills all the information into one piece of literature that you can look at. They were actually asking people that were actually dealing with flaky tests about how severe they saw the problem. And they were saying that it's a frequently encountered problem. So 20% of the respondents were claiming to experience it monthly. 24 encountered it on a weekly basis, and 15 even on a daily basis, which is like worrying in my thinking. So the 91% of the developers who claim to deal with flaky tests described, more than half of them described it as a moderate problem, and nearly a quarter of them described it as a serious problem. And 97% of the flakes, in their opinion, were false alarms. So the code worked as expected, but the test still failed. And more of 50% of those test cases could not be reproduced in isolation. So basically, that led them most of the time to think, OK, we can ignore these. Can we? Is it fine? I don't think so. So I'm expanding a bit on the impact of Flakes itself. So basically, what we do in automated testing is we want to have like a reliable signal of stability. If any of these tests fails, this gives like the red flag for that we can't release, basically, because it's unstable. Something has failed. We need to look into that. But like a flaky test, as we saw earlier, just fails for some other reason, but not because the code does not do what it should. So this is just basically wasting our time. So from a community perspective, they also cause issues because we have like limited resources in CI. So we need to make the most of the CI resources that we can. And any run that contains a flake is wasted time. It doesn't help us. So, which basically means that other PRs might get delayed because there was some waste in that, and you have longer waiting times until your PR will merge. Also, the sad thing is about, for example, like Prow does a smart thing. It merges together a couple of PRs and tests them all together. If there is a flake, that effort is wasted. And yeah, basically, all is waste of CI resources. So for the individual computer, there's also things that cause issues on that. Basically, the individual contributors want to have their things merged as fast as possible, which is obviously, you want to get things done, right? But yeah, like flaky tests just hinder you in achieving that. And what happens then, at some point, you don't trust the test anymore, which is you don't care about the test results. And that's very bad. So let me tell you what we did to try to tackle this problem. A couple of years ago, we started already with that. We were wanting to achieve one goal: flaky tests must not enter the code base. How do we want to achieve that? We were like trying to run them on a basis like we were looking basically at the files that have been changing. Then we were determining from that which tests have been changed, and then we were running them. Basically, we were running them 5 times in random order. So the reasons for 5 times is basically from the previous survey that you saw. One of the results was that 88% of the flaky tests were detected within 5 runs. I mean, there is a 12% miss still, but yeah, it's good enough, hopefully. At least that you would catch the majority of the flaky tests. And the random order comes probably, someone knows probably why we are going to run that in random order? Test dependency, anyone heard of that? So like one test pollutes the test, sorry. So one test pollutes like the test environment, because we're talking about E2E tests, you need to have like a separate setup that is reused for many tests, because it takes time to set up the whole environment. And therefore, we run them in random order to catch all these things, where one test pollutes the test environment and others suffer from that. Yeah. So, yeah, it's lame. It's a bash script. I agree. But yeah, still it does its job. So what you see here is that we have like, this is just the part that is relevant. For Ginkgo, it's the randomized all flag that we use. And we had just run it in a loop. So this is like the environment setup that you can see here. And then, yeah, we just run them just a couple of times afterwards. This is our situation in CI. So we have done like a heat map about how fast the test runs. Basically, what you can see here is there is time windows in which the majority of tests fall. Like the white area is like the 10 seconds to 1 minute, which is around, I've done a lame screenshot here, I didn't attach that. This must be around like 800 tests that are in that ballpark. And then the second largest area is the 1 to 2 minutes range. So like 200 tests are taking 1 to 2 minutes. So you can probably imagine how much time we waste by a flaky test with that, if there is one flaky test inside the test lane. So the problem is that we have like the 12% remaining that actually like might not find the test, which is a problem. So basically what you want to do, it's not working half the time. You want to have the exact number of tests. What we are doing with our approach, or what we were doing with our approach was we were just looking at the test files, and because we couldn't, we are running with Ginkgo. Ginkgo has like a kind of tree structure where the tests are organized. So it's not that easy to find the exact test case that has been changed. I mean, it's doable, but we didn't somehow care. We just wanted to have like a first starter so that we would run the tests in random order, which is a problem when you have big test files with many tests, because all of these are being run. So that basically means that at some point they might run into a timeout, because you have when you have hundreds of tests, they might consume like several hundreds of minutes. And because I think our timeout value is like a couple of hours, it might run into a timeout. So we had to do some capping. So we would like estimate like how many tests are being run. And if we thought like it would exceed a certain boundary, we would not run that lane, which is bad. Yeah, but it's like that. And the other problem that derived from that was CI users would basically complain about tests failing on them, which they didn't touch, which I can understand. I mean, like there is collective responsibility and so, but that's another topic. But still, I can get that. So that if I didn't touch a test and it's failing on me, why should I bother? There is reasons for that, but I can understand the complaint. Yeah, basically the rerun lane also takes around 1 hour on average, which is also like a time constraint that we have. We wanted to go get better on that. So the main point is the only way that you find a test is to run it as often as you can, because like with the 88% chance, you might still miss them. So the survey says that there were tests that were even flaking after 10,000 runs. So, which, as you have seen, like when you're looking at the majority of tests running 1 or 2 minutes, this is not doable. Or, yeah, maybe everything is doable, but yeah, like with resource constraints, you might not be able to do it. So enter CANNIER. So CANNIER tries to fix that problem by cutting down on the number of tests that you are going to rerun. They are actually like trying to guess or to predict how flaky a test is. In order to then, if you know whether it's flaky or whether it's unflaky, to not run it. That's basically the idea. So they were saying that their studies found that they could cut down the rerun time that was spent there on an average of 88%, which is like a lot, even when you're multiplying like your test run times, right? So what they do basically is they have a random forest model, because that's basically a decision problem that takes a couple of features from the code, puts them into the model, asks for the prediction, and then gives 1 of 3 ranges back. So you would basically see like this is the upper threshold. That would be the positive predicted class. So these would be the tests that would be flaky with a high probability. Then you would have the lower threshold, which would say those are pretty much stable, so you don't have to run them. And the interesting part would be the part which you don't know, like the rerun class. So you have like the boundaries which you then can decide with whether you're going to rerun the test or not. So here's the complete set of features. I don't know if you can see that, can you read that? Okay, so that's good. But I've already done a little bit to help you. So there is two parts of the features. So there is basically a set of runtime features that you're going to consider, which is like, yeah, read count, write count, memory consumption, other things that you can see or record at runtime. And there is also a feature set of static analysis data, which is based on, for example, AST depth. So like how deep is my code in the test. Also, there is one other, like cyclomatic complexity, which gives me like an idea of how complex the test itself is. The others, I don't want to go into too deep detail. Basically, I can't explain them, to be honest, like in detail, because I'm just using it. So what we are planning to do is we are going to implement that, which looks like that. But we had questions. We thought about like how would we basically do that. So the CANNIER approach has a feature complete implementation, but it's in Python. I mean, everyone that is using Python here, you're good. You can just use it, which is great. So that's the good news. The bad news for us was we are based on Go. So we can't leverage that. But the authors of the thesis were saying this is basically language agnostic. You can just use it for any language, and it should work right away. But if there is no implementation, you need to think about how to implement that. So the problem was that we would also need to think about how are we going to store and to record all the data that we need to create the model with which we are going to do the prediction, right? So you have a couple of features that you need to record during test runs, and you need to store them somewhere. So also there would be the idea, when exactly do we capture them? Do we run them in a separate environment, or do we record the metrics all the time? I mean, that could be interesting, but that could also be like giving us an impact on the overall test runs, because it might add up to the test run times, which we don't want to do. We want to decrease the test run times all the time. And yeah, another aspect would be the data science part. So Python has well-established data science frameworks. I think there is basically everything that you would need. Go state, we were not that sure about that. So these were the questions. So what we wanted to do was we wanted to have an implementation that was basically largely Go-based so that we could maintain it. We also wanted to have like the separate parts all into separate CLI elements that we could use and then do the several things that we need. Like, for example, like generating the model data and putting that into a container and running that and having like a Kubernetes service for it so that you can just grab the prediction from that. That would be one part. And then there would be like the part where you would actually run the data and record the features, basically. We are halfway there, I must admit. We're not feature complete. We have basically like a prototype that is doing basically what it does, but the feature extraction is not entirely complete. We also need to sort out where we are going to store the data. We need to have something inside our kubelet cluster where we are going to store the features so that we can leverage that. The test lane also needs to be modified, but that should be not a big issue. And basically, also we need the deployment for the model. I'm always thinking, like, trying to think like into the future, and there is like, this was the first, like the basic feature complete implementation, but there would be more things that you could leverage from that. Because basically what you want is normally you want to have the model data as accurate and as recent as you can. Because you always want to use the most recent data to get the most precise prediction results. That's why we would be aiming for an automatic update of the model. Also, we would rather not want to run that as a prow lane because, we don't. First of all, we don't want to fiddle with the bash script basically, but we also want to leverage like the data that is extracted from there and give that to the user while they are working on the pull request. Because, like for example, cyclomatic complexity is a very interesting metric that tells the user whether his test would be too complex and would give him a hint so that he might need to reduce the complexity or split them into several parts or something like that, right? There is advice in there that you could give right away. That's why we would want to run it as a Pro external plugin. Also, yeah, I mean, not far from that could also be like a similar implementation where you would leverage those things inside a GitHub action, for example, so that you could run it without any Pro instance, just as a GitHub action. Yeah, that's what I was already saying. Yeah, one thing I forgot to mention was that basically what the interesting part about that is, if we cut down on the number of reruns that we have, we can increase at the same time the amount of reruns that we do. So if we decrease the set of tests that are being rerun, we can run them more often and thus increase the probability of finding the flaky test. And one other idea that stems from that is we could probably group the tests into categories because we have the runtime data. We have the time, how long they run, and we would probably run at first a set of fast executing tests, which would give us probably faster results so that we could improve on general like test detection. Okay, back to the current state. What we have done already is we have the logic to find the exact tests that have been changed. We have modified this flaky tests, check test for flakes lane to leverage that logic, so it runs definitely only the tests that have been changed. That is already there, which is great for us in reducing the overall test runtime. So basically what you would see, for example, if you look at the KubeVirt code base, KubeVirt has one file, for example, where there are several hundred tests inside. It's a lot more than one, right? If you're changing only one test. That helps. So some final remarks to the CANNIER approach. The CANNIER approach basically is language agnostic, which I already said. Our implementation will be highly dependent on the Ginkgo framework itself because we are focused on Ginkgo. And everyone else who also is using Ginkgo could already then also leverage that as far as we are. Basically, the adaptation to other usages of Go frameworks should be just an implementation detail. We could probably convert that into like a plugin system that would then just be exchanged when you're using some other framework. Okay, I didn't, how good are we doing with time? Okay. Okay, I have prepared a slide with links. By the way, I forgot to mention, I'm sorry for that. You don't have to do photos or something. I have included a couple of links to the slides so that you can just download them. But yeah, these link sections tell you about the initial pull request that we are working on. It also refers to an earlier presentation I did about like how we tackle flakes in general in the KubeVirt project. And it gives you the CANNIER paper link and the implementation for, as I said, Python. Yeah, download slides. I just wanted to combine that. And I think that's it from me, and I'm ready to open for questions, if you're okay with that. So basically, you were asking whether the change would be, whether there would be a difference between changing the test itself versus changing the test in production code? Yeah.
What about production code changes? I mean, I changed the code, production code, and that makes the code flakier than it was before. Like, do these tools actually figure that out?
I mean, flakiness is not related whether it's like going from the production code. I would agree with you that flakiness can come from either side, like from the test case itself, be it with like race conditions inside the test, or otherwise race conditions also in the production code. But the thing is, basically, that doesn't matter at all, because the flakiness itself is a problem, and whether it's originates from the production code or from the test doesn't matter at all, because still it's a flake, and you want to get rid of it. I mean, like, I would probably differentiate between a flake that comes from the production code versus a flake from the test. For me, a flake in the production code is a bug. I mean, that's like, but then probably I would say that the test itself would need to tackle that problem. Yeah, you might have some regression test for that, so that it proves that there is something that is wrong with the production code. That would be my approach, by the way. But basically, we are just trying to find the flakes and try to help the people to understand where the flakes are so that they can work on them. So, I mean, that's a group effort somehow. I mean, everyone should care about flakes, but we are trying to isolate them and to give like the right tool at hand to the developer so that they can see where it's flaky and hopefully even like be able to say, okay, these are the reasons probably. Does that answer your question? Okay. Yes?
Really, if flakiness comes from the underlying hardware infrastructure, like networks or this kind of stuff, is this good to impact the whole, let's say, methodology? Or?
So basically what we are trying to do in the Cupid CI, we are trying to, oh yeah, sorry. He was asking whether the underlying hardware or the environment that actually where the test is run does also have like an effect on the flakiness itself. Is that correct? Okay. So basically what we're trying to achieve is we want to have our testing environment as resilient as possible. So you can, I mean, there is also external services that we work with. What we have done, for example, we have implemented or integrated like an image mirror that would at least help us when there is an outage on the external repositories, for example. Also, you would probably try to not run the test when you know that they are going to fail. So like if you have an external outage, like if an external code hoster is not available, there is no reason to run that. And I think that this is basically like a different problem that we're trying to fix. So there is two aspects on that. So the first one is the stability of the environment that you're running your test, and the second one is that you want to have your tests as not flaky as possible. And this is actually just tackling the second problem. But yeah, there is also measures that you need to take to make your CI environment as stable as possible. Does that answer your question?
Not really.
Okay.
Usually you hope that your system environment is as stable as possible, but then you
Yeah.
Is this changing your model in a kind of way that then suddenly your tests are run, which you know they are not, let's say, the faultiness is not a flakiness to the flaky test, but the environment which was bad, instance, something was not right as it should have been.
I mean, that's a good point, and we are trying to isolate those instances of external failures somehow. So we want to differentiate whether the test or the test run failure originated from the code itself or from the environment. And that's what we are already separating. And basically, it should not have any influence on the model because it doesn't play a part. You take the environment as a given, and it should be as stable as possible. And if it is not that, then it shouldn't influence the model data. Did that now answer your question? Okay, thanks. Any other questions?
Don't you have experience that when you market test Flaky, developers kind of tend to ignore it for a while, and just because in our experience, every test should be fixed and should be deterministic, and Flakiness is typically a non-deterministic behavior, but still it should be fixed because it can possibly hide particularly good luck, which happens only when the sun shines and so on. So don't you think that you are trying to help developers to give them excuse to ignore the problem because it's a flaky test, we don't care. We will solve it maybe later.
No, actually what we are trying to do is exactly the opposite. We want to tell the people that is a flaky test, and we are going to tell those developers this is a flaky test, you need to care about this. So basically what we are trying to do is, the question was whether we are just providing excuses for our users to ignore flaky tests. Is that basically what you're saying? No, we don't. We just want to tell those people that are responsible, that have written those tests, your test is flaky, you need to care about that, you need to fix it. So that's basically what we're trying to do with that approach. But until now, we didn't have like a good mechanism to tell the people whether they would cause a problem somehow or whether someone else would cause a problem. So that's basically why we're actually targeting to make our test environment as stable as possible so that they would not have that excuse. And then we are now trying to find to prove this test is flaky, you need to do something about that. I mean, if tests already have entered the code base, then the problem's already there, and people might at some point just go away and not handle the problem, but someone needs to fix it because that's a community effort. We are talking about an upstream project, right? And everyone is suffering. Yeah. Okay? By the way, I only have 3 hats, but the first 3 would get like a hat if they don't have it already. I know people who have it. Yeah.
When are you going to be finished with your version 2?
That's a good question. Actually, oh yeah. When the question was when I'll be finished with the V2 approach of finding flaky tests. I don't know. Basically, I don't know. Like I said, we are in the midst of the prototype itself. We have still to tackle a couple of problems with hosting the data somewhere and finalizing the implementation when it comes to feature extraction. Yeah, that's where I need to find some time to work on that. But priorities.
Okay. I'm in the Podman project. We're looking into similar.
Oh, okay. I mean, I could use help. Any other questions? Okay.